Well, I was just machining some pieces the other day and was cranking along happily, and during a roughing pass, all of a sudden, the carriage stopped moving. And what actually happened is the thread stripped out of the nut here on the carriage, and now I've got quick adjust. Well, this is only a nut. This is M6x1 right-hand thread, so I could most likely machine my own nut here replacement and get this thing going again. But since it's the same system on the cross slide, I'm pretty sure that that is very close to giving up as well. And from constantly adjusting the play in these nuts, I know for a fact that the wear is uneven in the spindle. Same goes for the tool slides, and then there is a couple of very nasty gouges in the end here where I was cutting stuff up with a hacksaw and slipped. So added to that is some play in the spindle. I got most of the axial play out with the axial bearing I put in the back, 5 years back, but there is some radial play in the bearing that I just can't remove. Then there's quite some play in the idler pulley back here. Well, and then there's the overall construction of this thing. You see, where a normal lathe has a massive bed on which the saddle is clamped, the carriage is clamped and moves back and forth, this one has just a flimsy thin bar which is not suspended anywhere. And then there is this contraption of a sled on here which has a huge amount of overhang, and that just calls for trouble, doesn't it? The tailstock here has axial play like that for at least 5 millimeters, maybe even 10, which means that each time I machine something between centers, I have to manually readjust the taper on this thing by moving the tailstock left to right. What I'm trying to say is this thing is worn out properly. And yes, I can fix it, sure enough, and probably one day I will, but for the moment I think it is time for a new lathe that is designed more rigidly, because this is more of a clockmaker's lathe. It is designed to machine small pinions and machine pivots on tiny shafts, and just has the huge swing so some gear wheels can turn over here freely. It's not meant to take a millimeter depth of cut or even 5. So when I acquired this thing in okay shape, all I did over the last, how long do I have this thing, 6-7 years, was wear it out because I was constantly overstressing it. I am getting fed up with all the squeaking and rattling and chattering of the tool whenever I feed in some proper roughing cut. I am sick of having to crank this over and back all day long. I want an auto feed, and I want a machine that I can turn screw threads on. So it's rest in pieces for this one for the moment, and I'm going to take a look at buying a new lathe. This is what I came up with. Since I drive a Ford, it had to be a My Ford, and it's a metric version. My Ford has a very big name in the model engineering scene, and they're known for their quality products as well as their solid build concept. So there's very little overhang on the tool slide. The gibs are this long on this thing, so there is massive amount of clamp down and rigidity, even though it is still a compact lathe. This chuck is no larger than the one that is mounted on my other lathe, but it is a lot more rigid. It also has an auto feed, which I am so grateful for. And for once, it didn't sell for 6,000 euros, but I had to pay about a third the price, which is still a lot.
Here we go, money talk.
Here comes the money, 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 money.
But if you assume that I'm going to live for 80 years and this thing is probably going to accompany me for that time, then it's not that many euros per day. I think about 12 cents per day. So it's not just the lathe, it came with a couple of deal sweeteners, if you will. The cool part is that this thing sits on its own steel bench, so I don't have to give up any space. And given that I can get the other machine running again and sell it off, I have now an extra workbench to work on, while this thing can sit in its own place. Down in here you can see all the deal sweeteners I was talking about. First off, we have a set of taps, or high grade and Garant, which is a name quite well known for making good tools. Then we have a set of drills, which, when you take a look at my hodgepodge, is quite needed. Goes from 1 to 13 millimeters, I think. All high quality as well. Then I've gotten some insert tooling with it, and I'm not going to take out all of them. This here is, for example, an internal boring bar. There's a couple of them. Standard machining steels, a thread cutting tool and a parting tool. Along with that is a very big set of carbide tooling, you know, the ones with the soldered on tip, all sorts of things, left hand, right hand, roughing, finishing, round nose, pointed nose, thread cutting, boring, parting, all you can think of. Then we have a Röhm keyless chuck, which is very cool. And last not least, a couple of centering drills, high quality as well. So with those toolings alone and the complete change gear set, I think I have a very good base to explain why I invested a little more into this machine. But it also has a reason why it didn't sell for 6 grand. The lathe itself is basic. There is no milling attachment on here, there is no copying attachment, no attachment to turn tapers on. It has a clutch, which is some aftermarket accessory. However, there's supposed to be a lever over here to actuate the clutch, and there's just this plastic bit here, and if you pull that off, this is the sliding shaft which is supposed to engage and de-engage the clutch. So yeah, of course I was curious and took a look behind the blind here, and it's supposed to look like this, and on my machine it's just an angle piece bolted in there crooked, so the clutch cannot be engaged or disengaged, it's always on. Not too cool, but then again I can always use the belt tensioning mechanism here to activate and deactivate the spindle here. It makes a little noise while the belts are grinding, but overall very silent machine. Which brings me to the next point, because this thing is in tip-top shape. The spindle has 0.005 millimeters of play radially and 0.01 millimeters of play axially. The sled has basically 0 play in it. All that is backlash, a very tiny amount, I think 1/10 of a millimeter. You could even reduce that down. It's not worn out unevenly, the tailstock is dead center. It's just a lathe that I don't have to do everything about to bring it into operating shape. And that's basically what I wanted to avoid with this one. My choice was to get the Kosmos running again or buy a new lathe, and if I bought a new lathe and had to get it running again, well, what's the point? Which doesn't mean I won't have anything to do on this machine. You see, it only came with a 3-jaw chuck, and I would like to have at least the 4-jaw chuck and the outside jaw, 3-jaw chuck able to mount on this thing, and that means I'm going to have to adapt the chucks from my old lathe to this one over here. Tool clamping is also a thing we'll have to take a look at. This thing came with the standard clamp here, which I quite like, although it takes quite some time to set up a tool each time, and it's quite a mess having to take the individual shims for each tool around all the time. It also came with a quick change tool post, basically never really used. But the thing is, it's the El Cheapo brand made from aluminium, and if you take this thing and use it as the main means of clamping stuff down, then I just don't think this is going to last me any time. It's probably not going to be precise in repeatedly dropping in these cartridges in here, so I'm quite hesitant to use it. On the bright side though, I found out that my 4-way tool post that I made for the Kosmos is able to fit onto here. All I have to do is drill a bigger hole in the center and take some material off the bottom of this thing, and it's going to be drop-on install right on center height. Now this setup here with the nut in between as a spacer is of course temporary. You see this stud is quite long, and the threads bottom out before I would reach the tool post. And I would quite like to get rid of the nut here, having to use a wrench all day. This is an Imperial wrench, unluckily, so I'm going to have to use my adjustable one at that, and revert back to the principle on my other lathe with the fixed tightening lever. So I think I have two possible solutions to that. Number one is machine a new stud, make it metric 12mm thread, and buy one of these guys M12, just like I bought this one, or make myself a bigger version of this and put the proper thread into that. Now that means I'll have to adapt the stud that is currently in the compound slide, make the thread longer and probably chop something off the top, and I'm going to have to make the thread in here. If only I had the proper Imperial size tabs. Well, it just so happens I have a whole damn drawer full of British tabs and dies. Among it is the suitable 7/16 18 die, and the tabs are in here somewhere too. Might be this one actually, 9/16. Well, I'm going to look for that, and then we can start working. Well, there is a center drill already in here, and with the thing chucked it actually spins quite true, so I'd be foolish not to use it. And I'll just bring it in here, see that I can reach everything, which I can, and well, then we can go for engaging the feed, which I've never done in this workshop before. Okay, bets will be taken how often I will forget to close these oilers and have a nice oil bath the next day. So everything here is ready, and then we have two modes on this lathe. This is silent mode with the feet disengaged. It is also the manual mode, so if I wanted to crank about like on the old lathe, then this would be the way to do it. Or I can engage this tumbler lever here, and then when I engage the lathe, it's a tiny bit noisier, but now I have auto feed, and that's what I'm going to use. Now I'll still have to find a camera position which is going to work for both you and I, because the way it's sitting right now, it's completely in the way of my hands, but it's going to work for today. And eventually I think I'm going to go for the overhead position we had on the other lathe too. So I think it's fair to say we'll jack in 1mm and see how it does. Handled that just fine. Now we need to get down to 21mm, so that's what I'll head for. We're at 25 and a bit here, so let us try 2 millimeters. How about that? No problem. This is such a big difference. Oh, spoke too soon. The clamp here lost its grip. No biggie, I probably didn't tighten it down enough. Oh, just look at the chips fly. Nothing like the old lathe. So because I messed up, I'm going to check for size once again. And yep, we're at 23 and a bit. So 2 more millimeters should bring us right where we want to be. Right, shall we try parting off next? Okay, so I found me a parting tool among the many tools that the guy gave me. It's lived quite the life, and it's quite a wide one too. So since I can't resharpen it with my grinding wheel, what I'm going to do is take it easy and engage back gear, which on this machine you do by putting this lever into position and then loosening off this screw here and move the key out of the way, which engages the spindle to the drive pulley. And now, when I turn this guy here, you can see that the spindle thread is turning much slower now. Oh, wow, the top slide is interfering with the tailstock. So what I'll do is loosen the tailstock and the lock here as well, and then bring the spindle out a couple of turns, tighten this one down again, this one as well, and now we should have plenty clearance to try and see how this thing likes parting. The tool is very dull, but the machine doesn't chatter, which is good. I can tell you now already that I won't be going all the way through. I'll do the rest with the hacksaws. Oh! This is... I don't know, somehow the locking clamp doesn't seem to have the force I would like it to have. Okay, I can feel the pressure on the crank really increasing, so that's as far as I'll go. But it's doing fine. End is sawn off, parts back in the lathe, we're back to the longitudinal turning tool, and now I'm going to mark myself the 21 millimeters I need for the sphere, so that I know how long the handle needs to be machined down. There we go. If I remember correctly, should be at 19 right now. Nope, we're at 20. And we'll have to bring it down to 13. So, time-lapse engage. Now you can see I've already started roughing out the sphere contour here. The thing is, I've noticed that when I try and feed in with the compound slide, then the sled on the bottom is trying to move backwards. There is probably a carriage clamping bolt somewhere, maybe this one, or it's missing in here, or it's somewhere on this side, I don't know. And since I'm too lazy to run upstairs and get the owner's manual, I'm going to do a little trick here. And that trick is called disengaging the feed and engaging the feed on the carriage. And now, when I switch this thing on, the carriage does not move and it is locked, well, somewhat solidly into place. So now I can work with the top slide, cross slide, all day long. It only just occurred to me that it would make most sense to finish the sphere first before machining the taper on the other side, because I cannot clamp a taper in a 3-jaw chuck. So yeah, we'll freehand this sphere here first, and then we'll deal with the taper. Well, it looks a little bit like a sphere. That's mainly because the last time I was freehand turning anything on a machine that didn't have right-hand screw threads and the same pitch on both slides when I was in my apprenticeship, and that's about 6 years ago. So yeah, please excuse this. There is an amount of filing and sandpapering that's going to cure that issue in no time, and that's exactly what we're going to do. However, first off, I'm going to machine the taper, because that might just give me some new chucking marks on the sphere, and if I spend my time making it pretty right now, then most likely I will have wasted it. It's actually a very simple matter. You have one screw right here, one screw right here, loosen them, and we want about a 1 degree taper, facing that way of course. And after setting, just tighten them down again. Okay, engage our carriage locking mechanism, get our center in here. Oof, everything's in the way! Getting a little sidetracked here, the rear oiler was making problems. It looked like it wasn't letting any oil through, but taking a look at this lake down here and all this overflow here, and taking into consideration that it didn't take 5 minutes for the oiler to drain the complete reservoir, it was actually letting oil through. It just wasn't visible in this glass here. I thought I found the reason, I didn't. Well, I found it now. Just let me show you. These experts drilled the hole for the needle and seat at an angle. See that? And since this hole is so crooked, that means that the oil is traveling at an angle and it's not dropping straight down, but instead it's just diverted off to the side. So what I'm going to try first is deburr the inside here with a very small chamfer. hopefully this is going to be enough. Otherwise I'm going to have to solder it shut and re-drill it. Silly as it sounds. 3 hours I've been searching the error with this thing. And then when I screw it into the lathe, I bust the thread. Let's just get this handle done. I saved you polishing the ball. There's really nothing interesting to that. The next step, however, is going to be interesting. That's going to be getting the hole drilled into here, because it's going to be at an angle. And what I'm going to do is, just by eye, see what kind of angle I would like to have it in. Basically taking this as the reference surface. Matter of fact, I would like it a little bit shallower than what this one is. So comparing these two together, somewhere right about here should be fine. Tighten the chuck down, tighten it down real nice, and then make sure it's not interfering anywhere. And then we're going to have to center drill and drill on top from this side. Thread is in here, and my plan now was to take a stud, machine it down, cut a thread onto it, and use it as a mandrel to put this thing onto, and then face this side here flush. However, seeing how well it worked to file this side flat, I think I'm just going to do the same thing on the other side. Today is tomorrow. The next step on that clamping handle would be to machine down the stud. However, let's first fix this oiler here. I have the tap and die ready. It's 1/8 inch BSP. BSP stands for British Standard Pipe, and if you've never heard of that, 1/8 inch BSP basically means that nothing on the thread is 1/8 inch. It's not the diameter, it's not the minor diameter, it's not the pitch, it's not the thread depth. Nothing on this thing is 1/8 inch. And if you do know BSP, then please tell me what this is supposed to mean, 1/8 inch. Because I'm very curious how they came up with that number. I can't figure it out. Doesn't matter for this one though. We're just going to take this thing apart, drill this remainder here out, and then tap it 1/8 inch BSP, make ourselves a piece of threaded rod 1/8 inch BSP, screw it in here, tighten everything down, should be good to go again. Quite the experimental setup here. The stud needs to be machined down a wee bit in order to make the die be able to continue further on here. And in order to do that, of course, I need to find a different stud. So I managed to wedge an M12 into here and a nut underneath. Now that means I cannot move the top slide any, because the nut is too large to make it fit over the bed, and because the four-way is in at, well, the position that it's in. Everything's in the way, so I had to tilt that and extend the lead screw of the tailstock out all the way. It's pretty interesting, and hopefully it'll work for the little bit of machining I need to do. There we go. And there it is. 4-way tool post adapted to the myFord. Now, one last thing. I already noticed that the tailstock, whenever I work with a Lathe center, is most likely going to be in the way for me to reach in with the tool. First off, because the revolving center is of course larger than what I was used to on the other lathe, and then because the back of the tailstock is going to interfere with the compound slide. So I'm pretty sure that I'll have to rely on the original clamp here quite often. And in order to be able to use that, I'm going to have to modify the nut a little bit, because I've now shortened the stud height here. What I'm going to do is get rid of this spacer, which is going to give me that much more space, machine the contour of this thing to match this contour here, so it's going to sit deeper, and if still needed, I can always take a little bit of height off this nut in order to make it short enough to work on this stud. And there we go. Now I can use the clamp or the 4-way tool post whenever I want it. So versatile. Well, that's the myFord lathe for you. It's a whole different world than the old lathe. Before that, all the hand cranking and all the chatter. Now you just engage the feed lever and watch the chip quietly curl off the workpiece. It's a whole different world. A couple of you wrote in and said, oh, don't go too professional on a new lathe, it kind of spoils the fun of doing the impossible on such a tiny machine. But the way I see it, with this thing, the fun can begin. Thank you very much for watching. The Oilers!